right. Hitting the button. And you are live.
Do we hang on? We just like pretend that we're not live. Is that what we do? Is that how this works?
I think so. We're amateurs here.
Oh my word! I can see myself.
You guys are
we better start doing some work, Rob.
What's the
Hello.
work? What do we
Welcome everybody to this technical demo session. So today what we want to look at is a problem that I personally have. And I need to be able to selectively encrypt some data in my database. I don't want to use full database encryption. And I really kind of need to do this through application code, but I don't really want to use any application libraries because I don't know anything about encryption. I'm really not an expert. So my good buddy here, Rob Barnes, allegedly has a solution for me. Why don't you introduce yourself, Rob?
Hey, so yeah, like Nick said, I am Rob Barnes, and I'm a security magician in this sense, right? We're going to do some security magic. We're going to help Nick out with his problem. So like he said, he's got an application which he needs to selectively encrypt some data, and he doesn't want to do all of the cryptography himself within the application. Just out of interest, why not? Why don't you want to do that?
Well, it's simple. If you ever see my code, I mean, realistically, I think the key thing is that I've got two problems. One is I'm not an expert. I don't know which library to trust. So my kind of natural reaction when I'm thinking about Go is that, well, I'm just going to fall straight on Go's crypto libraries for a simple fact that I know they're really good. But the second problem is, what if I make a mistake? Like, I mean, I might make a mistake on the implementation. So that's like one of the problems. The other problem is I've got to kind of, well, I want to use kind of private key cryptography. That I think is the right thing to do in this instance. But then how do I store the private key? So like, if I have the private key on my application, if my application gets hacked, then the private key gets hacked, then basically they've got my data anyway. So these are kind of like the cruxes of my problem. So then I'm thinking like, well, okay, so do I then do something like asymmetric encryption? And then, okay, I can encrypt with the public key and then I can decrypt with the private key. And then it just sounds really hard, Rob. I'll be 100% honest with you. And actually I know for a fact that there is a better way. And the better way is that Vault has an encryption in transit or a transit secrets engine, which I can leverage as an API to be able to do this. So let me just quickly show you my problem, my application.
Okay.
So quickly just share my screen. So I have an application, and it's an expense report application. If anybody's been sort of following along the last sort of couple of days, you would have seen both Kareem and Rosemary using this application. Now, I've been doing some extensions to this application, so I can, let me just send an expense to this thing. So I'm just curling an expense to the application. And then if I query the database, well, what's happening is I found that people are actually doing smart things like putting their credit card numbers into the description field because the application doesn't support, all of those kind of fields. So people are hacking the system and they're doing things like, well, putting credit card numbers, PIR, all sorts of stuff like that into the description. And well, that's not great. So what I really want to do is I just want to encrypt that description field. People can whatever they want in there, but at least the data is going to be stored securely at rest. And I believe Vault's encryption in transit is just the job for that.
Exactly. So I think you've said a lot. So I'll kind of just fill in any gaps that you may have left. So Vault can help you with that problem. It'll do a pretty good job of doing that. So like you mentioned, we have a secrets engine in Vault called the Transit Secrets Engine. Now, Secrets Engine is the component of Vault which either manages the secrets or, in this case, manages the cryptography, right? So let's not worry so much about secrets management at the moment. Let's just think about cryptography. So Transit Secrets Engine is the thing that we're going to leverage, right? And it does a few things for you. It manages your keys, which is one of the problems that you mentioned. You don't want to have to manage that within the application. It's not even secure to manage that within the application. And when I say it manages the keys, it's not just a place to store cryptographic keys. It will also manage the life cycle of that. So, you know, if you need to rotate keys and all of these things here, your application doesn't really need to worry about all of that. Vault can take care of that side for you. And
sorry, Rob, just interrupting you. I never even thought about key rotation. Why is that important?
For a number of reasons, you know, it depends on your organization. Sometimes there are policies where you have to rotate keys every so often, and that's just part of your security posture. If there's any suspicion of any type of data leak or anything like that, you may need to rotate the keys. You know, you just have to be ready to be doing these things. Yeah, and, understood. You know, you just want to do it centrally. If you can just go to one place and then your entire application stack who's using all these different keys can just be rotated in that one place, then your applications don't need to worry about that.
Rather than trying to roll that over 100 instances of my application, it's just in one central store.
I mean, do you want to do that? I definitely don't want to do that. Yeah, so it will manage that for us. And I think you also mentioned that, like, Vault obviously is API first. We present you with an API. So the nice thing about that is you can leverage this API to pass it some plain text data using a cryptographic key that's in Vault, and it will give you back the encrypted ciphertext, and you can store that wherever you need to store it.
So I do have a specific requirement. So my specific requirement is that, like, I'm not a complete security noob. I have basic awareness of the principles. I want to create separation. So my app actually is two apps. I have an expense submission service, which is used by the kind of the web endpoint, by the mobile apps and things like that. And I have a report generation service, which is used by the back office. Now, all the sort of the expense application has to do is just store the data. We don't provide any way of sort of querying it, you know, particularly, but it's only the report application that needs to be able to query the data so that, you know, it can sort of finalize all of the expenses and then hopefully pay them back to me. So in an ideal world, what I want is that separation. I want the ability for my expense app to be able to encrypt data. I don't want it to be able to decrypt it. So if somebody hacks my expense app, which is the public facing one, you know, I don't want them to be able to grab my key and to be able to obviously just read the database as if it was plain text. So like Vault can provide this capability for me.
Yeah, absolutely. It's that's not actually a specific functionality of the Transit Secrets Engine. This is just built into the way that Vault operates. It's quite flexible in its authorization policy framework. So how we go about doing that is to design permissions within Vault. We have a concept of Vault policies, right? So it's just a policy document written in HCR. Generally speaking, as developers, you normally wouldn't need to concern yourself with that. You would just need to know what the endpoint is that you need to do. So what we'll do in your use case is we'll set up two policies. So we'll set up an encryptor policy, which will allow any identity that has that policy to use the key to encrypt data. And that's all it will be able to do. It won't be able to decrypt any data. And then we'll set up a second policy, and that will do the opposite. It will be able to decrypt the data using that key, but it won't be able to encrypt or do anything else. And then we'll just assign these policies to the relevant services. So that way you've got a nice degree of separation between the two, which I think is what you're looking for really in your app, isn't it?
Now, next problem. I'm using Kubernetes. How are you going to ensure that my application has the permission to be able to to be able to do the operation.
Yeah, awesome. So actually, before I move on to that, I just want to just make sure something's clear, just so that it's not misunderstood by you. The transit secrets engine is only going to encrypt and decrypt the data. It's not going to store it for you, right? So storage is going to be in your database or wherever that you're storing that information. So I just want to just make sure that bit's understood. But in terms of how your Kubernetes application can gain access to Vault and do these things here, the nice thing about Kubernetes is we have a Vault sidecar injector. And that takes care of a number of things for us. The first problem that we have is how does your application authenticate to Vault, right? So if we just go back to Vault for a second and we look at how it handles authentication, it does that using a construct we call auth methods, right? So it's the modular pluggable system that allows you to bring in your own identity providers, right? So as soon as you're using Kubernetes is probably the most sensible identity provider to bring this time. So what is a Kubernetes identity? It's going to be your Kubernetes service account. So what we'll do is we'll enable the Kubernetes auth method in Vault, and we will create a role in Vault. So role is just kind of a construct in Vault, which is going to map to policies. So we talked about some of the policies that we have. So what we'll do is anytime a specific service account authenticates to Vault, that it will be given a particular Vault role, and that Vault role is going to have that policy attached to it, right?
I'm going to put a service account onto my application. My service account has a token. The token's a JOT. It's cryptographically verifiable with the Kubernetes API. So I take that JOT and I use that to authenticate to Vault, and that gives Vault validates that that's correct. And then I can use the encryption or decryption, depending on which application I am. So all I need to ensure is that my application has the correct service account, and basically Vault sorts out all the rest. Well, a little bit of configuration. Exactly,
yeah. So essentially, you're going to give it the JOT or the JWT. I don't know how you pronounce it out there. And Vault is, once it verifies that with Kubernetes, it's going to exchange that for a Vault token, which is the core authentication construct in Vault. Everything always ends up being a Vault token.
All right, here's another one for you. Somebody gets onto my application and they steal my Vault token. Probably game over then, right?
Game over in terms of what are you worried about?
Well, are they going to be able to just do operations on Vault forever?
Oh no. So the good thing about Vault is tokens are, generally speaking, short-lived. So they expire. You can renew tokens. You can get new tokens. The idea is that the tokens have a life cycle, and that should limit the blast radius a little bit, right? So you can almost think about it as almost ephemeral access to Vault. Right, so that's the way to kind of look at it.
I like that. All right. Now, I've been digging through the docs. I think I can wrangle the Go SDK into action. One thing I'm not touching, Rob, I hate to say this, but like, you don't want me messing with the servers. I'm not your ops guy. I can just about manage a bit of code, but seriously. So you're going to need to set up all of this stuff. Would you mind? You show us?
Absolutely. I'll share my screen. And I don't know if anyone here is from the UK, but we have a phrase which comes from, I think, the 90s, where we say, Blue Peter, here's one I made earlier. Right? Is that ringing the bells for anyone? Sure does for me.
Yeah. I mean, you're trying to hide your age by not admitting that you know that comes from the 70s.
Okay, cool. So I have some code here, which we'll walk through. I'll just make this a bit bigger. So, like I said, the first thing we want to do is we want to enable the transit secrets engine, and we want to create a cryptographic key that this application can use.
So just for clarification, Rob, this is like something that you as an operator are going to configure for my application. It's not something that we need to set up every time.
No. So basically, what's going to happen here is that you won't have to run this code, right? You don't even need to concern yourself with it. The only thing you're interested in here is what the key is going to be called, because that's what you're going to have to run your API call against, right?
Yep.
So there's a number of ways you can configure Vault to do these things here. I've decided to use Terraform just because it's the easiest way to manage state. And Terraform has modules, so you can declare all these things in Terraform. You can write resources for the secrets engine, the keys, and so on and so forth. But what I've done is I've created a Terraform module which enables the transit secrets engine and gives us a cryptographic key. So if you look at this first block of code from line 3 to line 20, which I'll highlight there, that's just me calling a module. Which is available for anyone to use. It's open source, so definitely check that out. We can put links in the chat if you want to have a look at that there. And all we're doing is we're telling it the details of the key that we want to create, right? So we want to create a key called expense report service. Yeah. And we're just configuring a few things. We don't want to allow plain text backup. We don't want convergent encryption. We don't want it to be exportable. We do want to allow deletion, and that's only because we're running in Terraform. We want Terraform to be able to destroy this if required. But you configure that how you need. And there's so many different so many different cryptographic keys out there that the Transit Secrets Engine supports. We've gone with RSA 2048.
Because when we did our testing, we found that RS 2048 gave us the best balance between security and performance. But I mean, we could have used a 4096, or we could have used an elliptical curve key, right?
Yeah, exactly. So yeah, that's the key that we've opted to use here. And we also got sort of minimum encryption and decryption versions. And what that is to do with the key rotation, right? So if you encrypt some data with a key and then you rotate the key, it stores versions of that key. So, it's not going to break your application, So in terms of the minimum decryption and encryption version, this will kind of allow you to go back a level to be able to still access your data and not worry about losing that. So the module's going to take care of that for us. So we can run that. And then, we'll go on to your other problem about you want some separation of concerns, right? You want one service which handles the actual login of the expense to be able to encrypt that field that people are putting credit card details into, which ideally you don't want them to, but you just want to protect them and yourselves. And then you've got the other app that you mentioned, which is generating a report. So that is going to have to read that data there, right? So we're creating a couple of policies here, right? So this is a Vault policy, again, using Terraform resource. And we create a policy called report service decryptor. So this is doing the decryption. And again, written in HCL, just like Terraform is. Anyone that's familiar with Terraform, we're just basically saying that against this path here, which I'll explain that path in a second, we're giving it this capability, which is the update permission. Now, why that path is important is you'll come across this when you're working with the SDK is in Vault, everything is path-based. So when you run a call against the API, it will be your Vault address, port number, / the version of the API, which is V1 at the moment. It's the only version of the API we have, / the path, right? And this is the path. So it's the transit secrets engine that we're using. The action that we want to perform is decryption. And the key that we'd like to use to perform that action is the expense report service. And we're just giving permissions against this path to do this thing here. So that's the decryptor service, right? And then we want to create a second policy, which is for the encryption side. So this is to actually log the expense itself. So same kind of workflow, where this time, instead of decrypting, we're encrypting, but the path is otherwise identical to that. And again, we want to give it the update capabilities, right? So this is really nice. You now got your two policies in Vault. But it doesn't really mean much. You know, you've got the transit sequence engine, you've got your cryptographic key, you've got policies, but how do we use the things that we've created so far to ensure that the applications can do the things that you need it to do and that no one else can do these things here, right? So this is where we move on to the authentication piece, right? So we did talk about Kubernetes and the auth method and the fact that we're going to use Kubernetes service accounts as the identity, and we're going to map that to a Vault role. So we want to enable an auth backend, and that's going to be the Kubernetes auth backend. So it's nothing fancy here. We're just switching it on, right? But then Vault needs to be able to communicate with Kubernetes. So it needs to know a couple of things. Otherwise, you know, it's just not going to be able to talk to Kubernetes and manage these things for us, right? So what we're doing is we have another resource, which is just an auth backend configuration. And we just need to give it a few things, right? So we're linking this configuration to the auth method that we've just enabled. And we're giving it the address of our Kubernetes cluster. And then we just need to give it a few details about Kubernetes. So it needs its CA cert, it needs the JWT that's going to be used to kind of give it permissions to check these things. And also we need to know what the issuer is for that JWT. And in this case, we are actually disabling the issuer validation. We can not disable that if we want. But for the purposes of today, we're disabling that. We can change that in future if we want to.
So what's going to happen with this? So what happens is I give you, well, I don't give you, but I send Vault my service account token. Vault looks at that. It then makes a call to my Kubernetes API.
Yep.
It validates that the token is correct, the service account exists and everything is all good before it issues a Vault token, which is why. So the Vault is going to communicate with the Kube API, which is why it needs obviously the CA, because we're assuming it's going to be like a self-signed cert for the API, and it needs a JWT to be able to access the API. Sorry, that's right. Yes.
Exactly, yeah. And I think normally you wouldn't just be giving out the JWT, just the systems like that. But I think when you look at the role that Vault is going to play in the entire architecture, it's what you can consider trusted compute. It's essentially going to be a part of that security control plane. So you are trusting Vault by doing these things here, right? So just want to be clear about that, but that's exactly how it works.
And just one last thing as well. We operate a multi-cloud strategy. Surprisingly, we're using HashiCorp tools, but hey, we do, right? So I can actually have a centralized Vault cluster. If I've got multiple Kubernetes clusters, I mean, it doesn't have to be a multi-cloud solution. I might just have multiple Kube clusters because different departments decide to have their own mini Kube cluster rather than sort of namespacing things. Then you can set up multiple auth methods for the different Kube clusters, so they can all use this encryption and decryption process.
Yeah, absolutely.
For example, say I'm running my expense report on 2 different clusters. All you have to do is just set up 2 different auth methods. The key doesn't need to be distributed across multiple different things. It just kind of all stays centralized inside of Vault.
Well, yeah, so that's the great thing about Vault, but this is also the great thing about Terraform as well. So we can literally take this configuration and we could just change a few parameters, right? So let's just imagine you have a production cluster and a dev cluster, for example. The code that we're walking through at the moment, you can point this at a different cluster and it will deploy all of these things onto there as well. So you can do the same things on dev that you can do in prod. And yeah, in terms of the auth method itself, like you said, you can enable multiple auth methods. I mentioned earlier on, everything is path-based, so you would just enable it at a different path. So anyone that wants to, interact with the dev Kubernetes will go to whatever path you set for the dev one. If it's prod, you go for whatever one that is. We didn't actually set any path in this code because it will do so by default. But if you're doing multiple, you can set the path. It's just pretty simple.
And we're using the internal service reference here because we're actually running Vault on top of Kubernetes. But of course, you could use HCP, or you could have Vault running on VMs or on another kube cluster. And obviously, all you would need to change there is just needs to be a publicly accessible, well, not publicly, it needs to be a Vault accessible address, in which case this is, because it's all within Kube's networking.
Exactly that. So I mean, I don't want to go into any specific cloud provider, but if we were talking about HCP and you were, I don't know, you had your Kubernetes cluster on AWS and you had your VPC peering, that would obviously give your services in your VPC access to your Vault cluster in HVN. So it's the same kind of thing. It's just basic network rules.
Gotcha.
Just, is it contactable? So that's just us configuring the way that Vault can talk to Kubernetes to be able to say to Kubernetes, is this a valid JWT? Right. Kubernetes has the final call. It will turn around and say, yes, it is a valid JWT. So Vault will say, okay, here's a Vault token, right? And then the app can go forth and do the things it needs to do, right?
Nice.
So we have a Vault token now based on this kind of theory, but it doesn't have the policies that we created earlier on. So the Vault token isn't really doing much for our applications, which is where the roles come in, right? So we're going to create a couple of roles, right? So the first role that we're creating is for your first service, which is the expense service. So what's nice about this is what it's saying is if we're binding the service account name that comes from Kubernetes to this role. So if a service account called expense is the one that's submitting the authentication request to Vault, and it's all approved by Kubernetes, then it will assign this role. So we've got a role called expense, which is the same as the service account, just to make life easier. We're in the default namespace. In this example, you would obviously set whatever namespace your application is.
Generally, Rob, I just use default because I don't like using the -n command when I'm typing kubectl.
Yeah, exactly. So yeah, we're just in default, so that's fine. And the next thing is, so you remember you mentioned earlier on about what if someone were to get the token, what does that mean for your security, right? And I talked about it being short-lived. Well, essentially, what we're doing here is we're attaching a time to live or a TTL to that token. So it's going to expire in 3,600 seconds, right? Okay. So when it expires, you'll get a new token and so on and so forth. So if that is ever leaked, the impact of an exposure is significantly reduced. When we think about things like threat modeling, it's two things that we're looking at. It's the probability of an event occurring, and then if that event is to occur, what's the impact of that? So those are the things that we're trying to mitigate against, right? So here we're reducing that impact. Yeah. And then the final thing is we're giving any token that this role issues this expense service encryptor policy. So this is going to be able to any application that has this token is going to be able to use that cryptographic key to encrypt data.
So the role is a link between my Kubernetes service account and Vault's policy, which gives me the permission to perform certain actions within Vault, or in my instance, being able to encrypt or decrypt data.
100%. That's exactly how it works. Yeah. So you just think of it as a mapping. So we're doing that. That's the expense service, and we're essentially doing the same thing for the report service as well. You can see the only things that have changed here is that the service account names that we're binding to this role is now report. We obviously got a different name for this role, and the Vault policy is different. So this one is the decryptor policy that we created. So, the same rules apply, it's just a different policy, okay? And with that, everything in Vault is pretty much set up and ready to go from your application's perspective. So Vault's configured. Now, maybe we should walk through your app and see how we can make your app utilize some of the things that we've done. Unless you have any questions before we move on.
No, I know you're dying to just watch me write a bunch of bugs and see all my code fail. So let's go.
That's what always happens when it comes to you, Nick.
Okay. So my application is pretty straightforward. So as I was like saying earlier on, it's broken into two parts. I have an expense application which writes, and I have a report application which reads from the database. And it's just a simple RESTful application. So if I kind of like look here, it's a typical kind of Go app. I'm not using any fancy frameworks. Just using sort of Gorilla, but I'm creating a database, setting up a logger, and then just my router. And I only have two endpoints in this application: API expense, which is going to handle the receipt of my events and store it into the database, and a health checker for Kube. Now, one thing I do want to mention is that people are probably like going to be horrified in a little bit to see that how I'm managing database credentials and passing them to my application. I see you shaking your head. Maybe we'll talk about that another time, but Vault's actually got some handy tricks on that, and I'm going to pick your brains on that at a later date.
Nick,
But anyway, let's dig into this code, and I'll show you what I want to do. So my code is really straightforward. I take my expense, and this is what my expense structure looks like. It just has a name, a description, trip ID, cost, currency, etc., etc. And I decode that JSON. Anybody who's familiar with Go will kind of see, they'll know this pattern here. Using the JSON decoder, decoding the JSON from the request body. If I have an error, I'll report that. And then all I'm doing is inserting that into the database. So just quickly kind of show you there. There's nothing fancy going on in here. I'm using the SQLX package, which I really like for Go, and I'm using the MySQL driver, and all I'm doing is insert into expense, blah blah blah, parameterize query, and the values from my object. So it's pretty straightforward. It's almost as simple as you can get. But what I want to do before I do this insert is I'm going to hopefully be able to kind of get that description there and encrypt that data. So let's have a look. So to do that, what I'm going to do is I'm going to create myself a Vault client. Now, I'm going to use Vault's API, and Vault has a Go API, which we'll kind of share the links for, but you can kind of see this just there. But the reason that I'm going to wrap this inside of my own client is purely from a testability perspective, because in my unit tests and things like that, I can define a kind of a simpler, more abstracted interface around the operations. And the kind of the first thing that I want to do is I want to create a new client. So what my Vault client needs is a configuration. So the configuration needs the address to the Vault server. We're going to pass that in when we create the client. Then I'm going to actually create Vault's RESTful client using the SDK here with new client, passing it that config, and I'm going to set it the token. So you're going to need to be able to provide me the Vault token so I can pick that up from my app. I could have that as an environment variable or a file, or maybe you've got a cleverer way to kind of do that. We can look at that in a little bit. So then what I'm going to do is I'm going to encrypt some data. Now, if I want to encrypt some data, let me zoom this up. What I'm actually doing under the hood is I'm making a call to Vault's API to the transit secrets engine. And the transit secrets engine method that I'm going to call is, we'll get there. We will get there. We're going to get there in a moment. We're nearly there. Here we are. Is encrypt data. And the method looks like this. So This is the path that I'm going to call. And these are the parameters that my payload that I've got a pass vault. And you can see here that I can, I can do batch input as well. So I can encrypt multiple pieces of data at a single request if I want. That's obviously going to encrypt the data, and it's going to give me this response. So the SDK is kind of going to handle things like, handling the transport, handling the request, making sure that the token is set onto the request in the right location and things like that. But I need to kind of just implement those data struts. Now with Go, they're super simple. So I have an encrypt request. My encrypt request has a property, plain text, and that's all I need to send. Then that's going to get me back a response. The response is going to give me a request ID from Vault. It's going to give me a data block, and the data block is going to contain the ciphertext. So my function to kind of do that encryption looks like this. So I'm creating my encrypt data function. I'm going to specify the data that I want to encrypt and the key. Now, this isn't the key that I'm going to use for the encryption. It is the name of the key that you've set up for me earlier on. And that's going to just return the encrypted data as a string or an error if anything goes wrong. So the first thing you've got to do is that the kind of the plain text that you're going to pass to Vault's API has to be base 64 encoded, because it doesn't actually have to be text. I could actually encrypt a file using transit encryption. It could be a binary blob. So as long as I just kind of base 64 encode those bytes, I can use that in this endpoint. I'm just using strings because that's a simple example. And then I'm going to make a client request using Vault's SDK. It's a post because that's what the Decrypt Api requires. And I have to pass the path. So what's the path going to be? Well, the path is going to be v1, which is the version 1 of the API, transit /encrypt, and then the name of my key. So that is exactly as we have here. So
I also just point out that's exactly how we set up the policy as well. Remember earlier on, I was mentioning that everything.
Oh, the path thing. So everything in Vault is a path. That's the path.
Exactly.
I get you. So then what I do is I'm creating my strut, setting my data, and I'm using the SDK's method, set JSON body, which is a convenience method, which is going to convert my strut into a JSON payload, set it onto my request, and then I can make my request. Now, I do want to kind of like just mention that if you're using something simple like the logical secrets engine, if you just want to access sort of plain secrets in Vault, then the SDK has a more rich, sort of a richer API around those. I'm using the kind of the really sort of raw stuff, but you can see it's pretty straightforward. So I'm going to make that raw request. The raw request on the client is going to make the call to Vault. It's going to set the token and do all of that gubbins, and it's going to get me a request, a response back. So Vault's API, JSON API, it's RESTful. You could literally just be curling this, or you could even just be using Go's built-in net HTTP. There is no reason sort of, at all that you have to use anything fancy, but there's a lot of convenience around using the SDK. It just makes life a little bit simpler, and I'm all about that. So then I'm going to get my response. So my response is going to be of type encrypt response. So remember, it's going to have that request ID, that data, the encrypt data, and all I'm going to do is, again, I've got those helper methods in the SDK, so I can just do decode JSON to my type, and then I can get that ciphertext out of there and return it from my function. So that's, that was like pretty pretty easy. So when I want to use that, like how can I kind of go about sort of using that? Well, I can just use it like this. So what I can do is I can just call my Vault client. I've just got this as a property here on my strut. I'm injecting my Vault client. Go import, pick that up in a second. But I'm injecting that. I'm going to call that encrypt data. Oh, sorry, that's the wrong type. It's not the official one. I told you I'd make mistakes. There we go. Reference to my Vault client. Obviously, this is going to be an interface because then we're going to replace it for our unit tests. I'm cutting corners. I know this, but you know, it's still pretty easy. All of this code for reference, I literally wrote the entire application. I mean, Rosemary created the application in .NET. So we had things like the database, but I basically replicated all of her code and rewrote everything in this in Go in about 3 hours or so. So it wasn't particularly difficult. And that was everything. It wasn't just adding the Vault stuff. So I encrypt the data. I'm encrypting the string from my expense. I'm using your key that you're providing me. And then what I'm going to do is I'm going to set that back onto my expense object before I insert it into the database. And everything should just work. Promise?
Fingers crossed.
Yeah. So the decryption. So I need to handle sort of decryption as well. Now, decryption is going to be in my other service, but what I'm going to do is I'm creating a shared package. This Vault client is going to be the same as my database client, is shared across my two services. If you want to kind of go and keep those independent, like you can do, but in this instance, they're pretty tightly coupled anyway. So, you know, it's absolutely fine. You're not really breaking any sort of microservice rules or anything like that, if there was such a thing. So decrypting data. So what that looks like is, again, we need to kind of create a response, a request. I need to be able to create a request because I'm going to call a slightly different API. I'm going to call a Decrypt API. Now, my Decrypt request is very similar to my encrypt request in that at a top level, it's a JSON block, which has a single parameter called ciphertext. And that's going to give me a response, which has a parameter data, which has a parameter plain text. So it's, you know, it's fairly similar to what we've just seen. And the function for doing my decryption, well, it looks like this. So again, decrypt data, the string that I want to decrypt, and the key, not the actual key, but the name of the key. I should just rename this name key, shouldn't I? That I'm going to use for decryption. So again, walking through those steps, I'm making a call against Vault's API. Now this time, the API that I'm going to use is Decrypt Data. So again, the documentation I'm just using to be able to find all of the parameters and various things. It's actually pretty good. I'm wishing that I'd wrote it because I really like it. But everything is there that you kind of need in terms of the various input parameters, etc. So that request there, you can see here that we're going to kind of just do that ciphertext, and it's going to give us back a response containing the plain text, which is, again, base 64 encoded, because my instance it's a string, might not be. You might be encrypting a file. So we get that back. Again, all of the kind of the requests, I'm creating this this Vault client request, which has all of these nice helper methods. So I can just use set JSON body. If you were doing this just using plain net HTTP, you're going to use JSON, JSON.marshal things, or the encoder. I'm going to return an error if anything goes wrong. I make the raw request. I do the decryption, decode this JSON that I get from Vault back into my entity. And then what I can do before I return it, because it's going to return me base64, I'm just going to base64 decode it and return the plain text from my function. So it'll be, it's pretty straightforward there. Like, just to kind of show you the difference there, again, I'm using like transit decrypt. Now, because of the way you've set up the Vault keys, Rob, even though I've got my encrypt and my decrypt methods in this same package, if I use a token, if I have a token for encryption, say in my expose service, I'm not going to decrypt, will just fail. It'll give me like a 403, right? So I don't have permissions to call that API. Is that correct?
You get a permission deny, correct? Yeah. It's very
granular,
least privileged approach.
Yeah. And then vice versa, obviously my report service, which can decrypt, will not be able to encrypt because it doesn't have permissions to call the encryption path.
Exactly. It's exactly how it will work.
Perfect. So let's look at the implementation of that inside of our report app. So if we go over, just closing the, oh gosh, I have like so many windows.
So this is how Nick writes a lot of bugs, you can see.
I write bugs. I think you've got to have a lot of files open if you want to write a lot of bugs. So my report application is exactly the same. Well, it's not exactly the same, but it's very similar to the expense application. It's just a pretty bare bones Go microservice. So I have a logger that I'm creating. I'm just sort of reading in some environment variables, which will allow me to do some configuration, creating my database connection. And again, I'm using that shared package. I then create my expense handler, which has two endpoints, a health and a get method for expense to return the expenses. So let's look at that. So my health handler just looks like that because everybody implements health handlers like that. That's why your code doesn't work, Rob. That's why you can't trust your Kubernetes liveliness and readiness probes, because you're just doing that.
No comment.
That's what I do anyway. They're fine. But the handler itself. So what are we doing? We're not doing a lot. It's a really straightforward service. I'm getting my expense items from the database. So again, using that SQLX, all I'm doing is select from star from expense items, and I'm just returning that object. The really nice thing about SQLX, as opposed to just kind of like pure Go SQL libraries, is that it kind of wraps a little bit of functionality, which I'm kind of on a tangent here, but I like it a lot. So I can make a select statement against my database. I give it the query, and I give it an object, or sorry, a strut that I want, well, in this case, a list, that I want the query to be decoded into. And SQLX will automatically decode the data from the table rows into this list of expense. And all I have to do is just simply augment things with the ID field. Brilliant package. If you're not aware of it, check it out. Big props. Back to the point. So that's all I'm doing. Now, the problem is that get expense items, the expense items are obviously going to have the description field encrypted. Now, I don't want that. For the report, I need to decrypt it. So how am I going to do that? Again, actually really simply. So what I can do is I'm going to take those encrypted expenses and I'm going to create myself a new list. I'm going to loop over my expenses. And for every expense, I'm going to call the Decrypt Data method on my Vault client. So that's the one that I've just written here, which is in my core shared package. That's going to make the call to Vault. It'll decrypt the data. I then set that back onto the object. And then I can basically return that to the end user. And it's really, it's really that straightforward. So the only kind of last little tweaks that I really need to make is, well, I need to I need a couple of environment variables because I'm gonna need to be able to know where the Vault server is. And I'm going to need the Vault token, I guess. And then I can just, create an instance of my Vault client and pass it into my my handler, which is like pretty epic. So where am I going to get the Vault token from, Rob? How do I get the Vault token? Because what I have is a kind of a pretty bog standard Kubernetes deployment here.
So we mentioned earlier on that there's the sidecar injector.
Okay.
So that's what you're going to want to interact with, and you can just do this in native Kubernetes. You just need, so you're on annotations at the moment. You just need to stipulate a few annotations, and it will transparently take care of all of this for us, right? So I think there's an interesting one at the bottom there, the cache and agent cache enabled, which pertains to a problem that you mentioned earlier on about the token expiring and how it's going to keep it updated. This is the thing that's going to allow it. So as long as you set those annotations, your application should be able to grab that token and off with Vault.
Okay. So I own this config file. So as a developer, I can manage these annotations. I don't need to do anything else other than make sure I've got the right service account and the right annotations. So the agent inject annotation, like, correct me if I'm wrong here. So what this does is when I submit my pod to the Kube cluster, Vault has a Kubernetes controller running. The Kubernetes controller picks up that annotation and it will automatically add a sidecar to my application, which is responsible for communicating to Vault and getting secrets and all sorts of things like that.
Exactly.
Yeah.
So that's the whole point, is that sidecar injector can take care of that whole Vault interaction for auth.
Yeah.
And your application need not worry about that, because can you imagine if you had to? I mean, there are cases where some people have to do this, but if you have to implement the whole authentication flow inside of your application, there are so many different use cases that you need to kind of build your application to have resilience against. So
Rob,
just having Vault agent do it transparently.
I've done it. I've been here. I've been there.
There you go.
There you go. I exist before this magic was around. I've had to do this the hard way. Well, and I'm
take
thankful.
A break. You can retire from the hard way and live the easy life from now on. The Vault sidecar injector will do it for you.
And then that's going to create an init container, which is going to do the Vault authentication. It's going to take that Kubernetes service account, pass it to Vault, exchange it for a Vault token, and then that's going to set up the agent running as my sidecar. So I have to specify the role that I'm going to use, and that's the one which is linked to my service account. We're just keeping things like a one-to-one mapping because it's nice and simple, but we don't have to. And now this agent cache enable. So this is a little bit of secret sauce, right? So when we were kind of saying you need a Vault token, and I was asking you, how do I get a vault token to my application? The thing that you didn't tell me was, I don't need one. Because what you didn't tell me was that the sidecar can automatically proxy the requests for the app and automatically add the correct vault token to the request. So basically, what's the address of the vault server? I don't care, and I don't need to know, because I'm just going to use localhost.
Just talk to the proxy.
Talk to the
proxy
proxy.
will take care of it.
What's the
That's
token?
all you have to do.
Don't need to care, because the proxy's got it, and the proxy's managing it for me. So I don't need to worry about rotations, renewals, or anything like that. That's all 100% transparent for me. I like this.
That's exactly why I didn't tell you.
So that's all there is to it, really. You know, we've got the service account there. We're doing some bad stuff, and I did say earlier on that look, never do this. Never ever do this. Don't put, well, for a start, don't have your MySQL database credentials as root and password, but you know, don't pass credentials like this in a way that can be discoverable. This can leak into your CI/CD. It can leak into your Git. Like it's just bad practice. Now, Vault actually has some capabilities, and if you watch Rosemary's stream yesterday, sorry Barry, if you watch Rosemary's stream yesterday, she showed how Vault actually has dynamic database encryption capabilities, so you can actually inject a dynamic database credentials. So we're just keeping things simple, and that's all there is to it here. So let me just I don't need these things here because I've already got those configured. So let me run my expense report. Okay, apply. Oh, wow, you know, that is in my muscle memory now. Right. So the pod's initializing. I've just restarted my application there. Now there's only one container specified in the app, but I've got two declared. So let's take a look at that. And if we just back scroll a little, what you can see is, where are we? There we go. That Vault agent, which is automatically added to the thing. And there's somebody at my door, which my dog is ecstatic about, as you can hear. So what we're going to do now is let's kind of just run that curl again. So I'm going to just curl that API expense at the server, and just to kind of show you the payload there, because I don't kind of want to hide anything. This is the payload that I'm sending to my API. Now, if I select from my database again, you can see my previous row, which was using the old version of the application, which is not encrypted, and my new version, which is encrypted, and this is Vault's ciphertext. The V1 there is the name of the key, because if we're using sort of multiple keys,
it's the version of the key.
Good thing, right?
It's the version of it, of the key.
Yeah, sorry, yeah, that's, I mean, the key version. Yeah, sorry.
Yeah.
So that's awesome. So let's clear that database down, and let's just apply the same thing to our report. So let me just go and clear this up, because I don't need this. Got my service account. Again, those same annotations. The role is obviously different because this is the report app. So I'm going to get a different key with different permissions. Correct. Everything else is the same. Please don't do this MySQL thing. Like, I'm a bad human. I know it, but you know, please don't do this. Do this.
Oh, you're a good human. Bad developer. There's a difference.
Yeah, good point. Good human, bad developer. So let's apply this one too. And so we can see there that is initializing. And what have I done, Rob? Broken it. Rob.
What have you done? Let's have a look. Crash loop back.
Let's just clear this down.
Come on,
We were actually creating this stuff with Terraform, so with hence that error message that we got before. Okay, so now there we go. I don't know why I thought it had 3 containers before. It must have been a that was Kubernetes' fault. That was not my code.
No comment.
Shout out to DigitalOcean. We're using DigitalOcean docs today. As a dev, I think this is probably the simplest way to run sort of Kubernetes in production, dev or test or whatever you want. I love this system. I think it's really good. So we're going to just insert a record into our database. We're just going to check that that's there. We can see it's there. We can see the ciphertext. Now, if I retrieve that data, then what you can see is I've just hit the this public API is my report, and you can see that I've actually got the decrypted text there. So everything is working. I wasn't lying. There is no smoke and mirrors. There was a little bit of a bump, but that is literally how you can use Vault's encryption service or transit secrets engine to do RSA key-based encryption of your data. So we're encrypting that, storing it at rest on Kubernetes. And it's easy enough for me to understand. I hope that you all too can understand. And if you can't and you have any problems, then please look out for us. Either we're often on the streams. You find the live streams going on Twitch. You can ask questions on HashiCorp Discuss, the forum. We're happy to answer anything on there. And if anybody does have any questions, we're happy to hang around on the stream for a couple of minutes. I know we're kind of running 3 minutes over. Catalin has a question. Rosemary has answered it, but yes, it would work with stored procs, Catalin, because all you're doing is you're encrypting the text using Vault's transit secret before you add it as a parameter in your stored procedure. Like theoretically, and I know you can do some really fancy stuff with database stored procedures, which you should probably never do, but you can do it as a neat experiment. In something like MS SQL, you could actually make a direct call to Vault. You could even have your MySQL stored procedure calling Vault to do the encryption. You should probably never do that, but you probably could. But in a direct answer to your question, yeah, absolutely, because all you're doing is exactly the same as what I'm doing here. I'm just encrypting the parameter before I pass it to the stored procedure or the SQL query to then be inserted into the database.
Okay,
well,
I
want to say thank you very much
to the live stream,
Rob.
there.
This has been super informative for me. I appreciate everything you've done to help me, and I'm really excited to be able to use this and to keep things safe and secure. Like and subscribe. This is really important, people. But that's what YouTubers say. Anyway, we better go.
We're both YouTubers anyway, aren't we?
We are. Oh yeah, check out DevOps Rob's channel and mine
True.
as well. I haven't really seen it.
Nick's channel's magic, but yeah.
Thank you for
Appreciate
now.
love. And definitely also check out Rosemary's live stream from yesterday, which is live on YouTube. Some of the problems that we talked about here.
And also
Oh,
Kareem's, where he goes into depth on how all of this functions with Terraform, and which is kind of actually a really excellent way of managing Kubernetes. So those 3 parts hopefully will keep you going for a little while. Enjoy KubeCon.
Thank you so much, people.
I'll see you next time.
Peace.